A common byproduct of oil and gas exploration and production is the deadly gas hydrogen sulfide, or H2S. The Occupational Safety and Health Administration, or OSHA, requires that workers at risk of hydrogen sulfide exposure be properly trained. The American National Standards Institute, or ANSI, goes a step further and recommends that all workers on sites with hydrogen sulfide hazards be H2S certified. ANSI H2S certifications are sometimes required by law and are often required by employers, unions, and insurance companies as industry standard best practices. ANSI H2S certification is given out by your employer after they have verified that you have all of the required training. That training must include all of the information in this course, as well as site-specific training and orientation, training over your specific job duties, and training over the use of required safety equipment, including respiratory protection. ANSI H2S certifications are valid for 1 year. When you have successfully completed this course, you should be able to identify hydrogen sulfide characteristics, sources, and hazards. You should also be able to recognize hydrogen sulfide regulations, training requirements, and standard safety controls. Finally, you should be able to identify proper emergency response procedures for hydrogen sulfide. Lesson 1. H2S Basics. Hydrogen sulfide is a naturally occurring chemical compound produced during the decomposition of organic matter. It is heavier than air and soluble in both water and oil, and is often found in places such as bogs, swamps, and sewers, as well as deposits of natural gas, crude oil, and sulfur. It is highly toxic, able to overwhelm and kill almost instantly at the highest concentrations. It is also corrosive and flammable, making it a major hazard for workers on oil and gas sites. Hydrogen sulfide is colorless, and at low concentrations, it has an unpleasant, rotten egg odor. It is known by many different names, including sour gas, swamp gas, sewer gas, H2S, sulfane, and others. For more information about the physical and chemical properties of hydrogen sulfide, click the link on your screen. As we said before, hydrogen sulfide is a naturally occurring component of many oil and natural gas deposits. If an oil or gas formation contains too much hydrogen sulfide, it is considered sour. Drilling these sour formations and removing and disposing of the hydrogen sulfide creates numerous serious hazards for workers on the site and for surrounding communities. Hydrogen sulfide can often be found in and around areas of equipment that hold or process drilling fluid and raw formation fluids, including the wellbore, rig, mud pumps and cleaners, shale shakers, and well test equipment. Because hydrogen sulfide is heavier than air, it stays low to the ground and can collect in low-lying areas or confined spaces, including mud pits, gas venting systems, basements, and substructures. Energy industry workers have some of the highest risks of hydrogen sulfide exposure. This is particularly true of workers involved in petroleum, natural gas, or geothermal drilling, production, well servicing, completion, processing, refining, well plugging, and abandonment. Other activities that can carry a high risk of hydrogen sulfide exposure include pipeline maintenance, excavations, trenching, tunneling, and confined space entry, particularly in pits, tanks, sewers, and basements. Tank gaugers, caisson workers, and underground utility workers are also at risk, as are coal gasification workers, pyrite burners, and blast furnace and coke oven workers. Outside of the energy industry, hydrogen sulfide can be found in many fields, including agriculture, mining, waste treatment, and the production and processing of a wide range of materials and products. Depending on the type of work done on your job site and the level of hydrogen sulfide risk, there are a number of different regulations that may apply. OSHA regulates hydrogen sulfide under the Toxic and Hazardous Substances Standard and requires that all employees with occupational risk of hydrogen sulfide exposure be properly trained and protected against the hazard. The Environmental Protection Agency, or EPA, regulates situations that could cause a potential release of hydrogen sulfide, which could be hazardous to surrounding communities or the environment. In the oil and gas industry, many companies are also required to abide by hydrogen sulfide regulations put forth by ANSI, the American Petroleum Institute, the International Association of Drilling Contractors, and others. Other regulations that sometimes come into play include state and local regulations, Bureau of Land Management regulations, Coast Guard regulations, and others. Your employer should inform you about all of the regulations that apply to your job. Lesson 2. H2S Toxicity Hazards. Hydrogen sulfide can have negative effects on many different body systems, but the most strongly affected are the respiratory and nervous systems. Inhalation is the most common and significant way that hydrogen sulfide can enter the body. When breathed in, the gas irritates the nose, throat, and respiratory tract, and in higher concentrations, it can cause fluid to build up in the lungs or even paralyze the respiratory system. Once in the lungs, hydrogen sulfide is quickly absorbed into the bloodstream and distributed throughout the body, where it interferes with the cell's ability to process oxygen and begins to affect the nervous system. Cell death and neurological damage can eventually occur. Hydrogen sulfide can also irritate skin and eyes, even at relatively low levels. Compressed, liquefied hydrogen sulfide gas can cause severe damage to skin and eyes. Because hydrogen sulfide is a gas, ingesting it is uncommon, but it can occur if a person accidentally swallows water or other liquids which contain dissolved hydrogen sulfide. Short-term exposures to hydrogen sulfide, also called acute exposures, can occur when there is an accidental or emergency release of the gas into the air. They can also occur when workers unknowingly enter areas where there is hydrogen sulfide without first performing atmospheric testing and donning proper protective equipment. One of the first things people will often notice is the smell. Hydrogen sulfide has a very unpleasant odor. It is generally described as smelling like rotten eggs, though at higher concentrations, it is sometimes described as a sickeningly sweet smell. Unfortunately, even very small amounts of hydrogen sulfide can quickly cause the olfactory nerves to become desensitized or even paralyzed, leading to a temporary loss of the sense of smell. At high concentrations, this process can happen almost instantly, so the victim may never smell anything at all. This is why you should never rely on your sense of smell as a way to detect hydrogen sulfide. Signs and symptoms of acute exposure to even low levels of hydrogen sulfide can include excitement or anxiety, irritability, coughing, sneezing, headaches, nausea, diarrhea, eye irritation and watering, sensitivity to light, drowsiness, dizziness, confusion, and a staggering gait. Individuals with asthma or other breathing problems may begin to experience airway constriction. Poor memory, loss of appetite, loss of sleep, and even cardiac problems and motor function problems can also occur after acute exposures. Concentrations of 100 parts per million or more are considered immediately dangerous to life and health, or IDLH for short. At these concentrations, workers may experience problems with breathing and can become impaired enough that it can prevent them from escaping the area. The higher the levels, the more severe and rapid the effects can be. Chemical pneumonia, convulsions, collapse, cardiac arrest, coma, brain damage, and death can all occur. At levels of 500 to 700 parts per million, workers can collapse and lose consciousness within a few minutes, and death can occur in less than an hour. At the highest levels, immediate collapse or knockdown and paralysis of the respiratory system can happen within 1 or 2 breaths, and death can occur within minutes. Long-term or chronic exposures occur when workers breathe in small amounts of hydrogen sulfide on the job every day for months or even years. These amounts are usually small enough that there are few or no symptoms at the time of exposure. However, over time they can still cause health problems. These include chronic headaches, nausea, breathing problems, loss of memory, decreased cognitive function, problems with motor function and coordination, heart problems, and sleep disturbances. Chronic eye exposure to hydrogen sulfide can also cause severe and permanent damage to the corneas, including blistering, pitting, and becoming cloudy or opaque. There are a number of personal factors that can influence how the body reacts to both acute and chronic hydrogen sulfide exposures. These include age, body mass, overall physical condition, and personal biochemistry. The presence of alcohol, medications, or illicit drugs in the body can increase the effects of hydrogen sulfide. What are safe and dangerous doses of hydrogen sulfide? OSHA prohibits prolonged exposures above an 8-hour time-weighted average, or TWA, of 20 parts per million. One-time exposures of 10 minutes or less may not be more than 50 parts per million. These recommendations, however, have not changed since the early 1970s. In 2010, the American Conference of Governmental Industrial Hygienists released new recommendations with significantly lower limits. They recommend no more than an 8-hour TWA of 1 part per million for prolonged exposure and no more than a 15-minute TWA of 5 parts per million of short-term exposure. Many other industrial safety and hygiene organizations echo these recommendations. The National Institute for Occupational Safety and Health also suggests much lower limits, recommending no more than an 8-hour TWA of 2 parts per million for long-term exposures and a 15-minute TWA of 5 parts per million for short-term exposures. While the laws have not changed, many companies are voluntarily updating their policies to reflect the lower recommended limits in the interest of worker safety. At concentrations of 0.0005 to 0.3 parts per million, a person with an average sense of smell will be able to detect hydrogen sulfide. At concentrations of 2 to 5 parts per million of prolonged exposure, symptoms begin. Even at this level, hydrogen sulfide is considered toxic, and workers should wear proper respiratory protection. Lesson 3. Other H2S hazards. Hydrogen sulfide is rated extremely flammable by the National Fire Protection Association. It has a wide flammability range, meaning it is flammable at both low and high concentrations. At room temperature, it can also easily combine with air to form an explosive mixture. Open flames, sparks, static discharge, and even excessive heat can ignite hydrogen sulfide. It can travel considerable distances along the ground, and if it encounters an ignition source, the resulting fire can travel rapidly back to the source of the gas. When hydrogen sulfide burns, it produces sulfur dioxide. Sulfur dioxide is a colorless, toxic, and highly irritating gas with a burnt match odor. It is also heavier than air. Due to the high risk of explosion and the extreme health effects of exposure, employees should never attempt to fight a fire involving hydrogen sulfide unless they have been given specific training. Hydrogen sulfide can also react with many other substances found on oil and gas sites. It can react violently with many oxidizers and acids, which can cause fires and explosions. It can also react with iron oxide, also known as rust, to form an iron sulfide that is pyrophoric when dry. Pyrophoric means it can catch fire simply by being exposed to air. Pyrophoric iron sulfide has caused fires in coke piles and rubbish bins and in operating equipment, including strainer filters, demister pads, piping, exchanger tubes, compressors, spent catalysts, tanks, and enclosed sulfur pits. When hydrogen sulfide dissolves in water, it forms a weak acid that can dramatically increase corrosion, pitting, and cracking of many common materials, including stainless steel and concrete. It can cause chemical reactions with a number of materials, particularly metals, which can release other toxic and/or flammable substances. Wet hydrogen sulfide reacts with stainless steel and actually forces hydrogen atoms into the metal structure, creating bubbles in the material that cause blistering, weakness, and stress cracking. Undetected hydrogen sulfide damage can cause catastrophic failures of certain pipeline metals, particularly steel. Because of the way hydrogen sulfide reacts with materials, special attention must be taken when choosing equipment if there's a reasonable chance hydrogen sulfide will be present at the worksite, particularly in wet conditions. Lesson 4. Protecting workers from H2S. When hazards exist in the workplace, we use the hierarchy of controls to address them. Elimination is the most effective control because it completely removes the hazard from the workplace. For example, if a process in a hydrogen sulfide area could be automated or eliminated, it would remove the need for workers to be exposed to the hazard altogether. Unfortunately, elimination of hydrogen sulfide hazards is not often a feasible option on oil and gas sites. Substitution, replacing a hazard with something less hazardous, is the next most effective control. For example, materials that are highly susceptible to hydrogen sulfide damage can be substituted with materials that are better rated for hydrogen sulfide environments, reducing the risk of material damage and structure failure. When elimination and substitution cannot reduce the hazard enough, engineering controls are implemented. Engineering controls are changes to equipment or the work environment that protect workers from hazards. Ventilation is an essential engineering control for hydrogen sulfide. Local exhaust ventilation should be installed over equipment that can release hydrogen sulfide, such as shale shakers. Negative pressure ventilation and airlocks should be used to isolate hydrogen sulfide in places of high risk, such as mud processing rooms, and positive pressure ventilation should be used in living quarters. Hydrogen sulfide scavengers can be added to drilling and completion fluid formulations, and mud weight controls can be used to prevent an influx of gas into the mud column. Corrosion detectors can also be used to detect potential damage to equipment. In some workplaces, burning or flaring hydrogen sulfide is used as an engineering control to minimize worker exposure, either routinely or in emergency situations. As we said before, burning hydrogen sulfide releases toxic sulfur dioxide. If flaring is used in your workplace, you should also be trained over sulfur dioxide hazards and how to protect yourself when flaring occurs. The next most effective controls are administrative controls. These are policies and procedures designed to protect workers. Training, warning signs, safety inspections, monitoring programs, and lockout-tagout programs are all examples of administrative controls. Hydrogen sulfide areas, facilities, pipelines, and flow lines must be properly identified with warning signs. Policies should be in place to conduct appropriate monitoring of hydrogen sulfide levels and wind conditions, worker locations, and potential ignition sources. In some workplaces, authorization or permitting may be required before high-risk work can begin. When appropriate, work areas should be ventilated before workers enter. Supervisors should verify that all workers in the area are properly trained and are properly using all required safety equipment. Untrained and non-essential personnel should be kept away from the site. Qualified personnel should be available to provide rescue or first aid in a timely manner. If IDLH concentrations are present, which for hydrogen sulfide is 100 parts per million or more, standby rescue personnel must be rigged and ready for the duration of the job, and workers should use the buddy system. Hydrogen sulfide detectors are a key tool for protecting workers and equipment from unexpected hydrogen sulfide releases. Remember that odor is not a reliable way to detect hydrogen sulfide, as it can quickly deaden your sense of smell. In workplaces where hydrogen sulfide is likely, detectors are often permanently installed near areas of risk, and most workers also wear portable hydrogen sulfide monitors. There are several common types of hydrogen sulfide detection, including colorimetric gas detection tubes, electrochemical detectors, lead acetate tape detectors, and sulfur titrators. They all vary in terms of precision, reliability, clarity of results, portability, and cost. Your employer will choose detection methods that work best for your work environment and must train you over the proper use of any detection systems in your work area, including the meaning of warning alarms and the proper emergency response when alarms sound. Personal detection devices must be worn according to the manufacturer's recommendation, on the outside of clothing and protective equipment, and within the breathing zone. The API defines the breathing zone as a hemisphere forward of the shoulders and within a radius of 6 to 9 inches from the nose. In other words, the breathing zone is the air that you are currently breathing in. Placing a personal detection device lower on your body, such as on your belt, may not give you an accurate reading of the air you are breathing. Detection equipment must be maintained and calibrated according to the manufacturer's specifications. In the past, hydrogen sulfide monitors were usually set to alarm at 10 parts per million. However, given the new, stricter guidelines, it is now recommended that monitors be set to alarm at 0.5 parts per million. This alerts the worker that hydrogen sulfide is present, and they must evacuate the area to reevaluate the working conditions. Lesson 5. Training and protective equipment. All workers must be properly trained over hydrogen sulfide hazards, detection methods, and controls. This includes warning signs, emergency procedures, maintenance procedures, inspection policies, and other safety systems in use on the site. Workers must also be trained over facility-specific safety policies and procedures, including engineering controls used on site, such as ventilation and flaring. They should be familiar with the design of the work site, the materials of construction and their vulnerability to hydrogen sulfide damage, and any hydrogen sulfide containment systems used. Site-specific safety meetings and orientations should be conducted anytime workers are assigned to a new site with a hydrogen sulfide hazard. At a minimum, site orientations should include routes of egress, use and location of wind indicators, emergency assembly areas and muster points, warning signals and how to respond, location and proper use of protective equipment including respirators, and proper use of personal detection devices. When hydrogen sulfide is present and confined space entry work or enclosed facility work is required, those workers must have specialized confined space entry training to address hydrogen sulfide risks in confined spaces. Workers should also be trained over any hazards related to working with or around hydrogen sulfide, such as the hazards of sweetening procedures and chemicals, and any other hazards that may be heightened in the presence of hydrogen sulfide, such as hot work hazards. When hydrogen sulfide is present and confined space entry work or enclosed facility work is required, those workers must have specialized confined space entry training to address hydrogen sulfide risks in confined spaces. Workers should also be trained over any hazards related to working with or around hydrogen sulfide, such as the hazards of sweetening procedures and chemicals, and any other hazards that may be heightened in the presence of hydrogen sulfide, such as hot work hazards. When all other hazard controls still cannot reduce a hazard enough, the final type of control we use is personal protective equipment. This is anything the worker wears to protect against a hazard, such as gloves, goggles, and respirators approved for use in hydrogen sulfide environments. This could be a self-contained breathing apparatus, or SCBA, with a use duration of at least 30 minutes, or a positive pressure airline respirator with a backup air supply. For exposures below 100 parts per million, air purifying respirators with cartridges for hydrogen sulfide may be used, but supplied air respirators are always preferable. Any respirator must provide eye protection or must be worn with tight-fitting goggles. For exposures of 100 parts per million or above, which are IDLH conditions, there must also be a standby rescuer equipped with a supplied air respirator and a hydrogen sulfide monitor. Workers must be trained over situations that may require respirators and the proper use and maintenance of respiratory protection equipment. This training must include a medical evaluation, fit test, and hands-on demonstration of respirator proficiency. Workers must be trained to properly use and maintain any protective equipment they wear and to calibrate personal detection devices. Lesson 6. API Well Drilling Site Classification. To provide some consistency in safety procedures at drilling sites likely to contain hydrogen sulfide gas, the API has developed a 4-stage classification system. This system is a form of administrative control. Each higher level of classification requires more stringent safety measures than the previous stages, ensuring that site workers have the knowledge and equipment they need to avoid dangerous exposure. The first stage is No Hazard Condition. This designation is used at drilling sites which do not have a known hydrogen sulfide risk. A no hazard condition site isn't required to keep any special hydrogen sulfide safety equipment. The next level of API drilling site classification is API Condition 1, Low Hazard. A low hazard drilling site is one containing less than 10 parts per million of hydrogen sulfide. Be aware that the API classification is based on older recommended threshold limits. According to the new suggested limits, even a low hazard site may present a significant risk to workers. A low hazard site must contain a warning sign with a green flag. All safety equipment must be maintained in good working order and kept in accessible locations. While it is not required, a properly calibrated, metered hydrogen sulfide detector is recommended. The third API drilling site classification is API Condition 2, Medium Hazard. A medium hazard drilling site is one with more than 10 parts per million but less than 30 parts per million of hydrogen sulfide. A medium drilling hazard site must be marked with a hydrogen sulfide warning sign with a yellow flag. All safety equipment must be maintained in good working order and kept in accessible locations. Equipment should include an oxygen resuscitator and a properly calibrated, metered hydrogen sulfide detector. Workers must remain a safe distance from hazard areas when possible and remain alert for audible and visible alarm signals at all times. They must also follow any guidance or instructions from the site operator. The fourth and most severe API drilling site classification is API Condition 3, High Hazard. A high-hazard drilling site is one with hydrogen sulfide concentrations higher than 30 parts per million. These sites must be marked with a hydrogen sulfide warning sign with a red flag. Warning signs must also be posted 500 feet from the drill site on each road leading to it. A high-hazard drilling site must have 2 usable exits. Each high-hazard site must be equipped with 3 windsocks with streamers to help workers gauge wind direction, and 2 30-minute self-contained breathing apparatuses for emergency escape situations. All safety equipment must be checked before each tour change and stored properly when not in use. Equipment must include an oxygen resuscitator and 2 hydrogen sulfide detectors, one of which must be a pump type with hydrogen sulfide detector tubes. All workers must be monitored for signs of overexposure. They must also have an established means of communicating emergency procedures on site, and contact information of people who must be informed in case of an emergency must be readily available. Workers must pay special attention to visible and audible alarms. Individuals without hydrogen sulfide safety training must not be allowed onto a high-hazard drilling site. Lesson 7. Emergency Response. All facilities with a risk of hydrogen sulfide must have a general emergency action plan that explains the steps to take during an accidental release or other emergency. Some facilities are required to have a hydrogen sulfide contingency plan as well. The purpose of these plans is to provide a logical, step-by-step procedure for responding to an emergency in your facility. Every plan is different, but it should include detailed operating procedures to be followed in an emergency, including the duties of specific personnel, instructions for alerting employees and the public, and the procedures for requesting emergency assistance or initiating an evacuation of the surrounding area. There should be a call list of people and offices to contact, including contacts for emergency medical services and residents in the immediate vicinity. There should also be a map showing the locations of public areas, evacuation routes, muster points, and safety equipment. All employees should be familiar with the contents of the plan and be able to access a copy in an emergency. Sites that have enough hydrogen sulfide to potentially cause a serious emergency for workers or the public will often develop dispersion models to help predict the area that is likely to be affected and to identify how changes to wind speed and direction might impact the dispersion area. Different escape routes may be developed depending on the direction of the wind, so there should be wind socks or other devices on site to help workers easily determine the wind direction in an emergency. If dispersion models have been developed, the predicted impact radius and various escape routes should be outlined in the emergency action plan or contingency plan. Your employer should train you over any dispersion models that have been developed at your site. If a hydrogen sulfide alarm sounds, choose an escape route that runs perpendicular or 90 degrees to the wind's direction. How far you will need to evacuate will depend on the conditions at the worksite. But as a general guideline, the Emergency Response Guidebook says people should immediately evacuate to at least 100 feet away from any spill, leak, or unexpected concentration of H2S and at least 1,000 feet away from large spills or heavy leaks. Depending on the severity of the incident, emergency responders may choose to order an evacuation of a larger area if necessary. Always familiarize yourself with emergency escape routes and muster points before starting work on a new site for the first time. Remain aware of wind direction and the closest escape route anytime you are on site. In the event of a hydrogen sulfide incident, your first priority should always be to ensure your own safety. You can't help anyone if you become overwhelmed yourself. You'll just become another person needing rescue. Somewhere around 20% of hydrogen sulfide deaths are would-be rescuers who went in without proper training and protection. Anyone who is designated to perform rescues must be trained in all appropriate rescue techniques and procedures used in the facility, including the use of emergency equipment such as escape respirators and retrieval lines. They must also be trained in basic first aid, rescue breathing, and CPR for hydrogen sulfide victims, and know how and when to call in professional emergency medical services. If you are sure that you will be safe doing so, move an exposure victim to fresh air and keep the victim in a comfortable position until medical help arrives. Don't allow the victim to move around more than they have to. Do not provide CPR or rescue breathing without special training, as you could be exposed to hydrogen sulfide in the victim's lungs or on the skin or clothes. If hydrogen sulfide gas gets in someone's eyes, immediately flush the eyes with lukewarm water for 15 to 20 minutes. Hydrogen sulfide exposure should always be treated as an emergency. The victim should be transported to a hospital for treatment as soon as possible and should not be allowed to return to work until cleared by a medical professional. Liquefied hydrogen sulfide gas can be particularly hazardous to skin and eyes, and contact requires special first aid that is different from many other chemical hazards. If liquefied hydrogen sulfide is used or stored on your site, you should receive additional training over first aid for accidental contact. Now that you have completed this course, you should be able to identify hydrogen sulfide characteristics, sources, and hazards. You should also be able to recognize hydrogen sulfide regulations, training requirements, and standard safety controls. Finally, you should be able to identify proper emergency response procedures for hydrogen sulfide.